as soon as I get this. Okay, we are now officially recording this.
Thank you.
Cool. All right, Dimitri, you're
1
on
second.
deck.
I'm
Sure.
Can you see the presentation?
Yeah, it's loading. See your avatar.
Yeah, I see your avatar.
1 second.
If you're not doing the whole desktop, make sure you've selected the correct window. That's a common problem. Oops.
So let me do the whole screen.
That'll work.
What about now? Can you see it?
Not yet.
Nope. I'm so jealous. I can tell that Dimitri is in an office.
And you see how well things are working.
So, somehow I'm getting disconnected all the time from my laptop.
People talk about working from home. In fact, I think it's the other way around. All of us are living at work.
Pretty much.
Oh, 1 second. What about now?
We see your image, but all I get is a blank screen with your picture on it. What browser are you using? That might make a difference.
Chrome.
I would expect that to work.
It says my screen is seen by other participants.
Not here, I'm sorry.
And I'm being disconnected all the time for some reason. Sorry.
Sorry. If it's, I don't know if I can present for you or put the slides up. It's so weird.
No, so I don't know. I can try maybe from my phone. I don't know if it can possibly work.
Yeah, are you doing this from a Mac?
No, it's actually Linux laptop.
Okay.
Do you want to send me the slides?
I have lots of animations, so it will be somewhat inconvenient.
Okay.
Sorry.
All right. Well, we can give Dimitri a minute to try to figure out. Just keep trying, Dimitri. Maybe we'll jump on to some of these other topics at the bottom of the agenda. The only other topic today, unless people have more things to discuss, was to talk about merging some of the CII projects. I can never remember what CII stands for. It is not the Construction Institute.
Core Infrastructure Institute.
Yep.
Initiative.
Sorry, initiative.
Yeah.
Core Infrastructure Initiative.
Yeah, there we go.
Yeah, it got into my head.
I think the long-term goal is you won't have to remember it.
Yes, fair. So David had put together a proposal that's linked in the agenda, and there are a couple efforts that were under the CII that we saw as this working group being a potential home for them. Where this gets a little bit weird, and I think maybe we're not going to be able to sort of flesh this all out right now, is many of these things require funding. Currently, this foundation does not have any funding attached to it, and I think the funding question is going to be something that we have to bring up in our next board meeting. If this, I think if this working group is just sort of looking at the projects from the project perspective, then they all make a lot of sense to me. But I think since the funding is so tightly attached to them, it's a little bit hard to discuss within this group. But I'm happy, David, if you want to talk a little bit more about them, or I think, for folks that were here last time, we saw the awesome presentation from the folks at Harvard on the census work.
So here's what I would propose regarding funding. These efforts are actually already funded, I think, through the end of the calendar year. So this working group doesn't have to make any decisions on funded as far as funding for the moment. They're already funded and so on. I think the goal was really to put them in a working group so that they have somebody to talk with, report back to, get feedback from, interact with. Now, the funding, I think the notion here is that moving of these things into the working group doesn't require new funding because they're currently funded. It also doesn't give them funding for the following year. And I think basically at least my theory was that this group would look over these things, decide which ones they want to continue and how, work with these folks. My expectation is that there'll be some suggestions on here's what we think funding should be, and then the governing board actually and other folks actually can make decisions about funding in the future. But I think the challenge right now is that the CII existed for 3 years. It officially disbanded. There were some activities that were felt to be so important that the LF didn't want to disband them, and so kept going. These three, this list here being some of those. And if the OpenSSF is interested in bringing them in, then let's get those coordinated, everything in one place, and then people as a group can have discussions. Because I don't think anybody wants to discuss funding without somebody looking it over and saying, yeah, does this make sense? Does this not make sense? That sort of thing. And I think that's what the hope is, that this working group could review and at least provide, that extra set of eyes on, and also, frankly, in the case of some of the Harvard work, I think there's hope that the Harvard work will result in products that can be used by this group to help identify the critical projects that need resources of various kinds.
So can I add a bit?
Please.
From my role in the governing board. So we will be two things. One is that we, between LF and OpenSSF, we very much want the OpenSSF project to be successful, and we want to merge these security related efforts so that they're kind of all working together and we get the benefit of of people with like minds and projects of similar sort of scope and needs are happening under the same umbrella. There are open funding questions. I think that we'll be able to work through those. We will have a discussion about funding at the governing board meeting, which is next week. And I recommend that this group proceed by, as David suggested, which is just thinking about, do we think that these things are aligned in charter and they make sense here? And we'll go forward and we'll figure out what needs to be done for funding. But between LF and OpenSSF, we're committed to making that happen. So.
Okay, so I don't know what the right way to do this is. I could propose a vote or something, or either within this group or later. But I think the notion was, that this working group decide, do they want to bring these projects in, and if not, that's that's up to this working group also. But oh, hey, wait a minute. Oh.
No.
Darn.
It's not working. And we want it to work. We really do, Dimitri. Okay. So, I don't know what the right way to do this is and such, but, I would eventually I'd love to see some closure on this, because, we want, as, Kay just mentioned, we want like-minded folks working together instead of in splendid isolation.
So that all makes sense to me, and I think it definitely fits here. I guess my only concern is just I don't know that anybody can actually make promises that we're going to find funding so far, like for 2021. So here or the LF, and so it'd be a little sad to move this over, do all that work, and then not be able to continue the work in 3 months and have the whole thing die because we couldn't figure out the funding situation.
I don't think I don't think those two things. Oh, hello. Can somebody reduce echo?
That was fun.
Well, that was fun. Okay, yeah. I think that's true actually, no matter what. But I personally think that moving into the OpenSSF increases the likelihood of it being funded, because I think one of the issues, if I were asked, hey, should I fund it, is, well, who's looked it over and who's monitoring it, and having a larger group be able to make commentary, feedback, and so on, I think increases the likelihood of that. Regardless, nobody can make any guarantees. I think there is an interest very much in continuing these efforts, but that's but I think putting them in a place actually increases the likelihood.
Yeah, so we have options for funding. I really encourage us not to get not to make that be a barrier to deciding whether we want to move them in. So, and the options for funding include LF continuing to fund at the current rate.
But is that okay? I don't know if that's actually an option though. So that's why I think it's a little bit premature.
I would suggest this working group not worry about the funding, because that's not really the job, I think, of the working group is making it technically good, and if there's funding needs, helping to work out how the funds would be used and making those proposals. But I think right now the goal is just to have basically provide a home for places for these projects, so that there's interaction where there hasn't been before.
Yeah.
Right, David. I would say you're completely accurate in that the working groups, we should just figure out technically what we want to do, determine what funds are necessary. So there are a couple other working groups that are having this exact same funding question, right? And what we've been telling people, oh, I see a slide. I'll make this
Dimitri, you cracked the code.
We did it.
Document what the funding requirements are, bring those to the TAC, and then we'll coordinate with the governing board and figure out how funding is going to work, right? So we have to solve funding no matter what. But right now, like Kay and David and everybody's saying, let's just decide if this is the right thing, and then go from there.
Cool. Yeah, I think from, in terms of technical and the work that's being done, absolutely, it makes a lot of sense in this working group. I'd love to see how, this group could help too with the work. I don't know if, it opens up some new doors for, making some of the work easier, better, or whatever. So that could be a good discussion once we do figure out the funding side of it, at least.
Yep. Well, I don't think we have to wait for that to at least start getting some. Harvard's already given a presentation. I know they're busting their butts trying to get the census data analyzed. And I suspect they'll soon have some interesting results about the developers that I'm hoping will help us better approach the idea of how do we invest resources effectively to improve security of open source software.
Yeah. I know there was a few discussions last time about people like, trying to figure out if we could look at some stuff lower down the software stack. So that could be something that we could chat about. Cool.
Well, the survey of developers wasn't limited to library packages, right? I mean, it was just if you are a contributor. It wasn't even limited to people who write code. If you contribute to open source software, please fill in the survey.
Mm-hmm.
So.
Yeah. It's I think the PDF's 350 pages, so a little bit hard to parse.
Well, and to be fair,
right.
it lists every option, like every country of the world there's page after page of countries. It wasn't designed for a short list of pages.
Yeah. But maybe he figured out how to present now. We should be okay. Yeah, I think maybe in one of either the next meeting or the following meeting, it would be great to maybe deep dive on the survey a little bit, if you don't mind, and then we can sort of learn a bit more like that, just like we did with the census. I don't think the Census 2 presentation went deep into like the survey and the developer survey.
No, we didn't.
Yeah.
Sorry. Go ahead, Jennifer.
Yeah, we'd be happy to, we can, we're still analyzing a lot of the data and going through, but we can give you some of the higher level insights that we've been able to find. Like David said, we're still, we're trying to bring it together, make it look pretty, and but we can look to have that ready to present for the next, and that's in 2 weeks' time, correct?
Yeah, I don't think we have anything. Yeah, I can put you on the top here.
Perfect.
Okay, cool.
So, I mean, Kim, I don't know what the process is here, but I would propose a vote either now or a schedule or something like that on, whether or not this is yes or no.
Yeah, TAC members, do you have a preference?
I mean, in general, I prefer offline votes. So like a poll or something we could collect rather than making people go through this and say things in person. But yeah, I think we could start it today.
That's a good point. That way we could have a record of it as well.
Yeah, time to think about it and stuff and not put people on the spot.
Yeah, offline vote sounds good.
Okay. How long? Through like next Tuesday or something, so people have a couple days, or?
Seems reasonable if we actually get it out today.
Yeah, I think that's good.
I have the amazing power of typing doodle.com, so.
You're nominated then.
Unless somebody cares, I'll just make one and I'll post in a moment a URL and also in the notes and also in the working group. Okay.
Well, yeah, since this is just yes, no, I think Doodle's fine. For things where there's like ranked choice, I think we end up having to use something else. But
yes, yeah, I think this is just a yes, no. But you're right. For ranked choice, Doodle, I don't think can do that.
I wish it could.
Me too.
All right, very cool. Anything else on that topic, or should we jump back?
I just want to make a quick point too. I like where we're headed in that when we were looking at, what menu of services could we provide and looking at potential candidate projects, I think this will definitely help, at least point us in the right direction or help with that. So very excited to see what comes up.
Awesome. Yeah, same here. I think, we can't boil the ocean and fix everything, but having this research from Harvard and stuff that actually gives us real data on criticality of these projects will help us sort of align them with the menu of services that we hope to offer. Short plug on that. That doc is listed in I can find it and pull it up and pull it back to the top, but there's a lot of good ideas in there. So if you have time and are interested, that doc is just to put in all sorts of ideas for how we could actually help open source projects and improve their security posture. So if you have any other crazy ideas, that we would love to add them add them to that list because we know it's not like a one-size-fits-all solution for projects. So cool. So thank you. All right. Dimitri, are you ready? You're muted because I muted you.
Yes, I connected from the phone. One thing I haven't figured out how to do is how to scroll slides back. So don't ask me to show the previous slide. Okay, so my name is Dmitry Vyukov. I'm going to present about Linux kernel security. And this is based on my personal observations over the past 5 years working in the area of Linux security. It's not that I did any kind of special research. It's just things I observed working on other things. My background, so I work in dynamic tools team at Google for about 10 years now, and we work on sanitizers, in particular address sanitizer, thread sanitizer, memory sanitizer, and hopefully you know those tools maybe. Those tools find bugs like use of the free, out of bounds access, data races, use of uninitialized memory. And we also do some hardening tools and bug detection tools for production, and some fuzzing tools, in particular libfuzzer and OSS fuzz. And in the last 5 years, I'm involved in a similar work for Linux kernel. We do bug detection tools like kernel address sanitizer, and we also do some hardening tools and some fuzzing tools, in particular syscaller and sysbot, which is kernel fuzzer and continuous fuzzing system. Linux kernel. So I like this quote a lot. Civilization runs on Linux. If you look around, everything is Linux, right? We have Android with more than 2 billion users today. We have cloud, HPC servers that all powered by Linux. We have Chromebooks, notebooks, IoT cars, even plants and space stations. And last but not least, our coffee machines. And security in all those things is critical. It protects privacy of more than 2 billion people. It protects corporate government information. It protects some safety critical systems. And it's the first line of defense for lots of external things like external network packets, untrusted application, virtual machines, and USB, NFC, and so on. I can even go as far as claiming that Linux kernel is the most security critical infrastructure project in the world today. There are some that are more kind of security important, but at the same time have much, much smaller scope. And if you think about security, probably the first thing is, you think about those loud box with logos, but that's really only tip of the iceberg. And the next thing you think about is probably CVEs. And there's some number for the kernel. Somehow in 2017, there were way more, and then past 2 years, there were 3 times less. The numbers are kind of reasonable for the project of such size. For example, past 2 years, there were 170 CVEs for the kernel. But that's really also just the next layer of the iceberg, because most of the security issues for the kernel actually are unaccounted that don't have CVEs. So the first part of the talk is about bugs, which is really the body of this iceberg. We run this continuous kernel fuzzing system, which is called sysbot. And for the past 3 years, it is deployed. It reports about 200 bugs each month. So in upstream, we found approximately 3,900 bugs and roughly the same amount in some other kernels. If you look at the rate of bug reporting, it varies, and it's also somewhat outdated information. But what I wanted to show is that it's not that it somehow goes down or like getting close to zero. It's really more or less random, consistent number of bugs. And we have graphs for the total number of bugs we reported, and we have. So this here, the horizontal line is 3 years we run the system, and this red line is number of unfixed or open bugs. And black and green lines are the total number of bugs we reported and total number of fixed bugs. You can see that interestingly, those lines can be roughly approximated by straight lines. And total number of open bugs, it still grows. So it's like, ideally you want to go with down, and before that it can plateau at some level, but we are not even there. We're still, number of open bugs still grows over time, roughly linearly from the time we started running the system. We have dashboard, it's open with all of the open bugs, and there you can see that there are lots of pretty bad bugs, like use of the free writes, for example, and you can see that lots of them have reproducers and they will bisected, so it's not that they're unactionable. And lots of bugs were reported, say 1 or 2, even 3 years ago, and they still happen. So I need to know that not all of bugs we find have security implications. We're finding just bugs and really different mix of different types of bugs. But due to the nature of the kernel, lots of bugs in the kernel actually have some security implications. Even, say, printing something on the console may be denying of service in some contexts. And sometimes even innocent bug types can result in critical security issues. And I will show examples on the next slide. So some of the bad things you find is some related to remote networking attacks. Some involved even overwrite of the memory caused by incoming network packets. Some caused just denying of service. And the last two, they manifested in reasonably innocent way, like some hanks or say silent machine collapse, which frequently also caused by, say, testing infrastructure issues, and usually those are even not looked at.
Hello?
Yes, and the next pile of bugs is virtual machine escapes. So we've seen cases where host can write, guest can write to host memory. We've seen cases where information leaks from the host to guest, which is particularly bad for cloud deployments. And again, some types of bugs, they manifested in a pretty innocent way. For example, one was just a memory leak. It wasn't even detected as a memory leak. It was detected just episodic out-of-memory conditions after running for some time. But in the end, it turned out to be full guest-to-host escape because this was caused by a page reference leak on the host. And another one was just a warning, which is usually also pretty low on priority list, but it was a warning to restore registers on the context switch, so it caused register leak from host to guest. And we've seen local privilege escalation and info leaks, and there are just too many to enumerate all of them. Some were actually observed to be exploited in the wild as well, but generally, the thing is that nobody analyzes those for security impact. So those that I listed, they were just discovered accidentally, and very few of them have CVEs. One example is USB subsystem. So we started testing USB subsystem by injecting network, packets that normally came from the USB cable, so pretending we're some USB device. And by now we found more than 300 bugs triggerable by any cable. So the specific thing about USB is that any cable you connect to the machine, it can talk to any driver and pretend to be any hardware. So it can be even charger cable. And the bugs include also memory overwrites, information leak into the cable, and other types of bad things. And we still have quite limited coverage for lots of drivers who just reached handshake procedure. So it's not that we have like near complete coverage. USB is not really a special subsystem. We pretty much finding lots of bad bugs in every kernel subsystem. And sysbot is not a complete solution. It's just one of the testing system, and I estimate total code coverage we reached so far at approximately 10%. And we only test one architecture, and when we run in virtual machines, which means we don't have access to lots of drivers, majority of drivers. and we only detect crashes. So for example, if security module permits arbitrary access or file access system is broken, it's perfectly fine with sysbot because it doesn't lead to any crashes. So another view on the bugs is via stable releases. So stable releases is what end users actually use. And I looked at the number of backports into stable releases. And for the last releases, it's above 15,000. And for the 4.14, it's even above 18,000 now. I looked at the sample of those backports. Most of them, more than, say, 95% actually fixes. So it's not that like new functionalities are being backported. It's actually like patches that fix something. And you can see that maybe the number goes down, but it's not true because newer releases, they are have shorter lifetime for now. So if we look at the number of backports per month, then the numbers actually go up. And for the latest 5.4 release, it's above 800, now 800 something. So it makes it something like 28 per day, each day for the past 10 months.
Dimitri, not all these backports are security fixes, correct?
Correct. Yes, but it's also not all security fixes are backported. So it's true both ways. We also have some fixes that are not backported, and like we know that there are lots of hundreds of them. We don't know about all of them because if we would know about them, we would backport them. We also have some hundreds of bugs that are just not fixed upstream, and we obviously have some bugs that are not found yet or not detectable, right? Because if we have lots of bugs in those parts of the kernel, it's reasonable to assume that other parts of the kernel also have lots of bugs. So based on this, I can conclude that every release contains more than 20,000 bugs. And it's not getting better over time, at least I don't see this from the numbers. And it also means that the bugs are being introduced at roughly the same rate, at least at the same rate, right? Because if we would be fixing them faster, then the introduced would get to 0. And those are not short-lived bugs that are being fixed within the release. Say it's normal to have bugs, right? That's all developed by humans. So if something introduced, noticed quickly and then fixed quickly, doesn't leave the release, that's fine. But those are all bugs that actually left the release and were released to end users. And then things get even more interesting because nobody uses upstream kernel. Everybody has a fork of the upstream tree. Every device generally has own fork, and every, I don't know, cloud, every supercomputer, every deployment. So there are also, I think, tens of thousands of those forks. And when you fork a kernel, you also fork all of the bugs that are in that kernel release. And effectively, each bug fork becomes a new bug for most practical purposes because different teams work on those forks, and it may be fixed in one kernel, but not in another, or it may lead to different conflicts, and it needs to be tested separately. So if we now multiply this 10K bugs by 10K forks, we get something like 100 million bugs for the industry to deal with, which is kind of lots of bugs. So I'd say goal should be to reduce number of bugs per release by 2 orders of magnitude to make the situation more manageable. Okay, so this is about bugs. The second part is about development process and particular aspects of the development process that affect security. So some patches get lost, and there was research done by people involved in safety critical systems. They concluded that about from 2 to 3% of patches being lost. Despite kernel patches are mailed to mailing lists. And I observed a number of fixes, and particular fixes for important security bugs being lost. And I have some hypotheses that there may be a bias towards actually losing bug fixes, because when a person works on some functionality, they usually have assignment at their company to upstream something. It's on their to-do list, so there are no chances that they will forget about this. But fixes frequently done as kind of a side activity. Somebody decided that they can fix it. They sent a patch and then they forgot about it, and it's not on any kind of their to-do list. And somebody introduced the term public 0 days, because those fixes, they disclose a particular bug, but then they're actually not merged. Then also some number of bug reports getting lost. And we actually also have some data on the sysbot suggesting that kernel bugs are either fixed right away or they just get lost and not fixed at all, because kernel mailing lists are kind of age triggered. So bugs are usually fixed when somebody receives an email. If it doesn't happen, then they're not fixed in most cases. And we've seen a number of cases where bug was re-reported. And that's really the way to kind of find those cases, because by definition, if it's just lost and never found, then like we don't know about those cases. So some more things on bug tracking. There's no general process for triage or security assessment of bugs. It may be somewhat different on the subsystem, because kernel rules for each subsystem are really different and they may work differently. Some subsystems are better, some are worse. But generally, there is no assessment from what I see. And then there are some unmaintained subsystems. In particular, frame buffer is an interesting one. It's unmaintained. It's enabled in all distros, and it's full of bugs because it's very old subsystem. And in some setups, it's accessible to users. So it again gives us lots of public 0 days. There's a number of other subsystems that have status orphan. And all of those that I listed, they're actually enabled in my current distro. And the USB one is interesting because, as I know, that any cable you connect to your box can really talk to any driver. And so it's not that you need to be trying to connect this particular hardware to expose those bugs. And yes, bugs are being reported on the mailing list, but nobody actually really reads them directly because there's too much traffic. And there is actually a bug tracker called Bugzilla, but usually bugs, for example, not closed in this bug tracker. And the main thing you want from a bug tracker is to get the list of open bugs. So if you don't close the bugs, that's not really the question you can answer. There are some other interesting cases, like, for example, an important developer wasn't aware of critical data corruption issue because the bug was reported in the bug tracker, which wasn't expected. Like, who would expect bug to be reported in a bug tracker? Then to have a secure project, we want to have some practices, security practices in the development process. So ideally we have tests, we have fuzzers, we use sanitizers, we use test coverage. If we don't use, say, fuzzers, then any bad actor just need to write a simple fuzzer for any subsystem and they will get exploited immediately. That happens all the time, always. And if we do this, we can claim that we know that we don't have critical bugs, at least for the level of testing we do. But this is not exactly a reality for Linux kernel. Very few new features added with tests, and bug fixes generally go without tests. At least for the thousands of bugs we reported, I've seen very, very few regression tests being added. Kernel developers generally don't do fuzzers. Again, rules are different, but I've seen only one subsystem, which is WireGuard, that was fuzzed before it was added to the kernel. And we constantly see cases where even exercising some functionality in very basic way, in the most basic way, with some bug detection tools enabled, exposes bugs, which means that it wasn't tested with this tool at all. And this harms fuzzing because the fuzzer starts hitting this bug all the time, because it's like you really don't need to do anything special to hit this bug. And I've seen an interesting case where I just executed cut on a file in sysfs, and it literally smashed kernel stack with that 90s style bug where there is a fixed size buffer allocated on the stack, and a sprint is done without the size check, and that buffer just happened to be like smaller than the data that's actually written to. So if you have read access to this file, you execute cat and you corrupt the kernel stack. And this was trivially detected with kernel address sanitizer. Yes, and test coverage generally unknown. I talked to lots of testing systems and kernel developer, like nobody had any idea about their test coverage. So this situation allows us to make similarly sounding statement, but it's slightly subtly different. So in both cases, we know about 0 critical bugs, but in one we know that they're not there, and in the second case we just don't know if they're there or not. Okay, stable releases. So stable is what users are using, or at least should be using. And there's no consistent process to identify backports. There are some processes. Developers may mark patches as they need to go into stable, but that's opt-in. And then there are some machine learning systems, but there's no explicit decision for each patch if it needs to go or not. As a result, backports for some critical security fixes sometimes backported after 6 or 12 months. This happens frequently. Some whole subsystems don't participate in this stable process. And one thing is that patches are being applied in the best effort manner. If there's merge conflicts, trying to apply them, they're generally just dropped. So there's a notification that this patch wasn't applied, and then anybody may act on this or not. In most cases, it's not being acted on. And again, so I did a special search just for those notifications and included KSN, and this gave me like 100, I think, of public 0 days, because first one that I saw is fix use after free in something, blah, blah, blah. And it was being dropped. And stable backports introduce also bugs. And in particular, I've seen case where it introduced the use after free on network receive path, which is pretty interesting type of bug. And we've seen cases where whole subsystems break on some stable backports, or when boot breaks. And this is not surprising because number of bugs is high, testing is not very efficient, so bug fixes also introduce bugs. I think the only mandatory testing for stable is build testing, which is really nothing, and then the rest is kind of optional. If person is not on a vacation, they may do some additional testing, and usually they do, but also we have those tens of thousands of bugs that were not detected on the release, which raises questions to the quality of the testing. Yes, and you might think that, say, broken subsystem or boot is not really a security issue, but this leads us to the next problem, which is upstream distros gap. So lots of distros tend to look at the CVEs, and that's what they track, and that's what they try to fix in their kernels. But kernel really don't work on the CVE level. Kernel works on the bug level. So distros say that we fixed all CVEs, we're good, and they assume that somebody, say upstream, actually filed CVEs for critical security issues, but upstream explicitly says we don't do CVEs, use stable. So upstream is also happy because they provide good stable tree for end users. And Black Hat's obviously super happy with this situation. The only party that is not happy is end users. And we've actually seen cases where bugs were abused in the wild in Android because there was no CVE for a particular bug. Yes, I don't know what's the solution. Maybe it's just stop issuing CVEs for the kernel at all. Because if there is 0, like it will be obvious that like this is not where you should be looking at. And actually, I'm not sure if it's a joke or not. Maybe it's not a joke. Yes, this last short part is about action plan, which I don't have. So the problem is not small and not local, not something that can be just fixed here and we're good. And this is actually where I want foundation involvement and, I don't know, ideas, support. Lots of the known solutions that work in corp environments that just don't work in the open source world. But I think this problem and the project, it looks totally in the scope of this working group, at least based on the name. So for what I think what we need to do is pretty obvious things. Like I think we need to reduce inflow of bugs significantly, in particular to make other processes feasible. We need testing, fuzzing, synthesizers coverage to be adapted as part of the upstream development process, so that we actually can make any statements about state of security. And trashing and tracking bug reports seems to be mandatory for securing end users. And for the how, I think there are two mostly independent parts of the solution, but they're also complementary. One is something that can be done by a special, say, task force and can be actually funded. And these things like testing infrastructure or static analysis infrastructure or test and fuzzing frameworks or, say, bug tracking system itself. And there's the second part, which I think can only be done in collective way if it's adapted in the upstream development process, which is actually adding tests and adding fuzzers and keeping those tests and fuzzers working, resolving static analysis warnings and trashing bugs, and so on. So it's reasonable to ask a developer to, say, add a test for their functionality they're adding, but it's not reasonable to ask to add a test, but also write the whole testing framework and the testing infrastructure and actually deploy and run all of this when they're adding new functionality. And I actually been in this situation. So this first part, the funded part, I think where the foundation can help, and I think this can be something funded. And the second part, as I said, can only be done in a collective way, but both I think mandatory, and like only where both we can actually improve the situation. And there's some things that the centralized effort can help for the second part as well, which is doing evangelism both for developers and for leadership, and just bootstrapping this process and setting some examples of adding tests, fixing things. And also monitoring, say if there's some critical bug that are not being resolved or some test is broken for a long time. So those special cases may be taken care of by this special task force. So Linux is a model of technology and innovation. I think it's just a very positively notable project in lots of other ways. And I think it fully deserves to also be the model of open source security. And with this, thank you, and I'm ready for questions or discussions.
Yeah, thanks for this. This was really good. I've got a comment about the a couple comments, and I know we don't have a lot of time here, so I'll be brief. One of the things about CVEs that I think maybe you know, I know you can't go backwards in your presentation, but you know, that whole thing about, oh, well, we've got all these security fixes upstream, you should just use the latest stable or something like that. We don't respect CVEs. Part of the other problem with if a security fix is not tagged with a CVE, most of the OS vendors like Red Hat, et cetera, they don't feel a forcing function to actually include security fixes unless there's a CVE tagged with it. So according to me, another idea might be just go through and create CVEs for all the security issues. I mean, that sounds really dramatic and you know, kind of counterproductive. But I think one of the things the foundation could do is confront Greg and Thomas and say, look, why are you, you know, please change your attitude about CVEs. And I think, oh, look, you went back. Well done. I don't know that we necessarily have a lot of ability to convince Greg and Thomas about the subject, but I've certainly heard Greg talk about it, saying, "Oh, CVEs are not important. People are only filing CVEs to burnish their careers, things like that." And it's like, well, okay, but look, a lot of people don't necessarily use the stable version. So anyway, that was one comment I had. I have another comment about an area. All of these sound, by the way, really good, Dimitri. I think they're excellent. I've heard your talks before Linux Security Kernel Linux Security Summit, and I think your work's really great. But another area I think that would be useful to encourage somehow are architecting anti-exploitation features. There's whole use after free. There's stack overflows, various other attack scenarios that seem like they're relatively easy for a developer to put in the kernel. And it seems like there would be an interesting thought process. I think, I know there are plenty of smart people thinking about this, but a thing about, well, are there ways to re-engineer how memory is allocated, stacks allocated, et cetera, to basically prevent whole classes of security issues, right, through the architecture of the kernel. So anyway, just a couple thoughts from your presentation. Thanks again, it was really good.
Yeah, if I can jump in, and I suspect some other folks, I mean, Keith Cook's been specifically working on the kernel hardening project specifically to identify and counter whole classes. As far as some of those memory allocation ones, though, I mean, those are fundamentally baked into C. Your solution is stop using C for some of these classes. There's actually going to be probably a panel in the Linux Security Forum coming up end of October about possibly switching in some cases, but that's a big issue, as you can imagine.
Yeah, we can discuss Rust or those sorts of approaches, which I think are, there are language-specific things in C, that I know make it tough. But then there are also common memory allocators, slab allocators, et cetera, in the Linux kernel that people are encouraged to use, right? And I think some of the pushback for adding what I call anti-exploitation features has been performance, right? We don't want to slow down the kernel, so we don't want to add these things, or we'll add them as config options that nobody uses. Right, so I think they're probably, and yeah, Case is doing great work at Google. I think he's phenomenal, and I absolutely agree. He is a very strong voice in this area. So kudos to him.
Thank you. So for CVEs, I get the impression that Greg is actually want to go in the other direction, which is convincing distros to use all of the backports, but I don't know, both ways can work. One potential option is there's a thing called issuing authority for CVEs. So if there is a problem of low quality of CVEs, then I don't know, Linux Foundation something can become issuing authority for CVEs and actually guard the quality and solve this problem.
That could be a great idea. Yeah,
that's called becoming a CNA. I'm actually going to be talking with some folks and with some other projects specifically about that. But that is definitely that's certainly a possibility.
Mm-hmm. And for the second thing, yes, I don't know, Rust maybe an option. Like so far, hardening technologies, they tend to kill more minor classes of bugs because the major is use of the free and out of bounds. I think those are still made. And also, so initialize memory, we mostly solved by just initializing all memory. It kills all of the information leaks. But this is opt-in because it has some performance impact. So it's up to distros to enable it or not. And for the use of the free and out of bounds, our biggest hope on the memory tagging technologies like ARMMT, which with the help of CPU can make actually protection from use of the free and out of bounds have reasonable cost. But this will not happen again in a year, and it's just ARM for now.
Cool. I think we're about out of time. We probably didn't leave you enough time for discussion, Dimitri, but thank you so much. I think we'll be continuing these conversations. Like, I would love to know from people here today, like maybe who at your organization is sort of working on Linux stuff, and how we can sort of come together collectively to help with some of this stuff, either through funding once we figure out how this foundation is going to be funded, or other efforts. So yeah, I mean, this is going to be recorded, or it is recorded. So if you want to share out Dimitri's presentation and sort of come back. I think Linux itself almost could be a whole, we're almost its own working group, but we're not even going to talk about that. I think this is a good place where we can make, some big impact, and Google is very much interested. So would love to hear from others, and maybe we can open up the discussion again in a future meeting, since we kind of ran out of time today. So awesome. Okay, thank you again, Dimitri.
Thank you for inviting me.
Yeah, of course. All right, have a good day, everybody.
It was a good meeting.
So
Thank you.
much.
You too.
Yes.
See you in a couple weeks.
Thank you.